I'm going to look at absolute and relative errors when we're dealing with floating point numbers. When we have a real number that we're trying to represent, sometimes we're not able to do that in a floating point representation because, for example, we might not have enough bits to represent that value exactly, and then we end up with a rounding error. So it's really good to be able to identify what the error is when we're trying to represent an actual value. And there are two types of errors. There's the absolute error and the relative error. We're going to look at each of these now, and then we're going to look at an example of this. So to calculate the absolute error, that's straightforwardly the actual value subtracted from the floating point value, and then it's positive. So that's what the two vertical lines on either side mean. So we would take the positive of that. And the relative error is calculated as the absolute error that we just calculated, and we divide that by the actual value. So let's have a look at an example of this. So we're going to choose our actual value here. This is the actual value 0.12431, and our floating point value is 0.125. So that's what we're going to calculate, both the absolute and relative error. So let's first of all calculate the absolute error. So the actual value is 0.12431 minus the floating point value, so that's 0.125. Then when we do that, and we need to make that positive as well, we get 0.00069, and that equates to, when we do all the rounding, that equates to 0.1%. To calculate the relative error now, we take that value there, 0.00069, we divide that by the actual value, so that is 0.12431. We'd make that positive if it wasn't already positive, and that gives us 0.00. Again, we've rounded this, which gives us 0.56%. So we normally present the errors in terms of percentage. So there we have it. We have the absolute and relative error for the values that we've put in.